Hello, in this video we are going to solve the following problem together. Mathematical Olympiad, Algebra, and the topic is numerical sums. Determine the exact value of this fraction. This has been chosen from an Iranian Telegram channel for Mathematical Olympiad. That's a good idea if you pause the video at this point and give it a try. But if you cannot solve the problem on the first trial, on the next slide I will show you a hint, somehow helping you to proceed. And on the next slide I will show you a second hint. And finally, on the last slide I will show you the final answer to this problem, so that if you have done it and finished it, so you can compare it with the final answer to be sure that you're on the right track. So if you do not want to see the hints, please pause the video at this point. This is the first hint. If b is positive and a squared is greater than b, first of all try to prove this equality. The square root of a minus the square root of b can be written in this form. On the next slide, as I mentioned earlier, I will show you the second hint. So if you don't want to see that, please pause the video at this point. For the second hint, I think that would be a good idea if you can try to prove this, which is a very simple fact. So you see on the left hand side I have a sum starting from integer m going up to another integer which is greater than or equal to m. On the right hand side you have a sigma with the same lower limit and the same upper limit, but the only difference is that the index, instead of just being simply k, is m plus n, the sum of these two numbers, minus k. You can pause the video at this point now, give it another try. On the next slide I will show you the final answer. The final answer to the problem is simply square root of 2 plus 1. Okay, so the first thing that I want to do is to prove this equality. Of course, if this equality is given to you, proving it is not that hard. For example, you start raising both sides to power 2 and then manipulate the expressions algebraically until you reach to an equality which you know is true. The only thing that you have to be careful in the middle of the way is that every line of reasoning that you have, any simple algebraic manipulation that you do, should also be reversible, which is not hard to track in that way. But let us be a little bit more creative. Let us say that we don't know the right hand side, and then we want to somehow construct this by thinking wisely. Because if you have a little bit of experience of calculating sums, one of the things comes to mind is telescopic sum, of course. And the good news, the interesting thing about this problem is that this is not a telescopic sum. So that is because most of the sums are telescopic sums, and then we find a way to make it telescopic and then solve them. But here, as you will see, it's not telescopic. But because we have that mindset, might be it is a good idea to ask ourselves that is it possible to break this, I would say, compound squares, because I have two square roots involved, to a sum or difference of two other square roots. So in other words, it might seem natural, based on, of course, experience, that you might ask yourself, is there any number x and any number y, so that I can write this square root of a minus a square root of b as, for example, square root of x minus a square root of y. Okay, so this is just a guessing to see if it is working or not. But then I'm trying to see if I can find such x and such y so that it works. Okay, I have square roots involved, so it is not hard to realize that, okay, the best thing might be is to raise both sides to power 2. So this one becomes the first one squared minus 2 times the first one times the second one, and then plus the second one squared. So I will manipulate it a little bit. So I would write x plus y together, and if you don't mind, let me flip 2 inside the square root, so it becomes minus the square root of 4xy. I am not claiming that this is guaranteed that this number should be a and this number should be b. But if I can find x and y in such a way that x plus y becomes a and 4xy becomes b, then I have my x and my y. Okay? So this means that I ask myself, is it possible to fine-tune this x and y so that x plus y gives me a and 4xy gives me b? It's a big question mark, okay? But then if I want to answer this question, that's very simple. For example, you can set up a second degree equation, or let us just do it in this way. I will find y from here, so it becomes a minus x, and plug it to the second equation. So it is 4x, but instead of y, I can put a minus x equals to b and try to find this x. So I multiplied, so it becomes 4ax minus 4x squared is equal to b, and I move everything to one side, so it becomes 4x squared minus 4ax, and then I have plus b equals to 0, and then I can use ABC formula to find x, so it becomes 4a plus or minus 16a squared, and then I have minus 16b, and everything divided by 8. But if I factor 16 out and factor a 4 out and then simplify it with the denominator, it becomes simply a squared minus b divided by 2. Okay, so there are two choices for x. Okay, but of course you know that this system of equations is symmetric. It is symmetric with respect to x and y. What does it mean? It means if I change x to y, y to x, the system will not change. So it is very clear that I have got two answers for x, but if I choose the plus one and put it here, the negative one will be the answer to the y and vice versa. So in other words, I don't need to do some more algebra to see what y is, okay? But I have to have a wise choice here. So in other words, what I'm saying is that one of these numbers is x and one of these numbers is y. Yes. So in principle, this can be x, and I put it here, and I will find y. You will see that if you do this simple algebra, y will be this one, and the other way around. But here I have to have a wise choice, because I know that the left-hand side is non-negative. So if I am looking for this x and y, I already know that x should be greater than or equal to y, not the other way around. So this breaks the symmetry between x and y. So now which one is x and which one is y? Of course, the bigger one is x and the smaller one is y. So this means that in this problem, if I choose x to be this, if I choose y to be this, I am done. So again, I hope that you understand the logic. I am not claiming that if this is supposed to be equal to this, this has to be equal to a, and this has to be equal to b. I am saying that if I manage to find x and y so that x is greater than or equal to y, and x plus y turns out to be y, and at the same time 4xy turns out to be b, I have the x and y that I need, and I was able to do that. So this means that now instead of this x, you put this expression, you will get the first term here, minus, and here is also minus, and instead of y, you put this expression, you will get the second one. So this is a very important one. And of course, you can simply prove that if there is a plus here, there will be a plus here as well. It depends which, if you want to manipulate the numerator of the given fraction or the denominator of the given fraction, you need one of them, not both. Okay? So I have decided to manipulate the denominator, so I have given you this as the hint. Okay, so now let us go to the discussion about the second hint. Okay, second hint is actually extremely simple. So let us just open it up. So the left hand side, if I open it up, what happens? It's sigma k goes from m to n a sub k. This means am plus 1 plus up to the last term is of course an, but the previous term will be an minus 1, the previous term will be an minus 2. That's the left hand side. But what is the right hand side? The right hand side, let me open it up. K goes from m to n, but a sub m plus n minus k. So if I replace k with the first number, it becomes m. M and m are cancelled, so I get n. So this becomes a sub n. If I replace a k with the next number is n plus 1, I will have m plus n minus m minus 1, so this becomes n minus 1. Yes, and if I change it with the next index m plus 2, I will get, sorry, that is n plus 1, n minus 1, and the next one will be an minus 2. And if I continue this list, for example, when I reach to n minus 1 and I replace this with n minus 1, it gives me m plus 1. It gives me m plus 1, and finally it will give me a sub m when I replace k with n. So now you see that of course these two sums are the same. The first one adds am to am plus 1 up to n. The next one starts adding the terms from the last term to the first term, but of course we know that there's no difference between how we add the numbers. Okay, it's a very useful and handy equality when it comes to manipulating sigmas. Okay, now let us solve the problem. The first thing I will do, I will write the numerator and the denominator of my fraction as a sigma, and I will call it x. So let me call x to be the name of my fraction. So then I can simply see that the numerator can be written in the form of a sigma, square root of 10 plus a square root of k. K goes from 1 to 99. The denominator will also be similar. So it will be sigma k goes from 1 to 99 square root of 10 minus square root of k. Okay, this is the x that I want to calculate. But let us concentrate on the denominator. So let me call d the denominator. So the denominator is equal to sigma k goes from 1 to 99 of the square root of 10 minus the square root of k. Okay, now I want to use the identity regarding the radicals that I actually showed you. So let me bring it in front of you. Okay, so this is the identity we proved. Now, comparing this with this, I want to give the role of A to 10, and I want to give the role of B to K. And I can use this theorem because the condition for this theorem to work was B positive, B positive, and A squared be greater than B. So if I want to give the role of A to 10 and B to K, of course, B is positive because K goes from 1 to 99 and all of them are positive. On the other hand, A squared will be 100, and 100 is always greater than B because B goes from 1 to 99. So everything is satisfied. So what I will do, it becomes sigma, K goes from 1 to 99. And if you don't mind, let me split this into two squares. So I will be a square root of the numerator and a square root of the denominator. And the same thing here. So this becomes 1 over square root of 2 square root of A plus square root of 100 minus K minus another one similar. Square root of 2 square root of 10 minus square root of 100 minus k. And now I split my sigma to two sigmas. So the first sigma will be 1 over, I flip the constant number out, it's a multiplicative constant, So from 1 to 99 of the first compound radicals plus minus the second one, similar. Okay, now something interesting happens if I use the second hint. So let me bring it here. Okay, so what I want to do, I want to use this relation in the second hint for this and for the first and the second sum, for both of them. Okay, so let us do one of them, the other one will be very similar. Okay, so let us concentrate here, okay? So what I can do, let me change my color here. This can be written as sigma, k goes from 1 to 99, so if you see the sigma here and the sigma there are the same, the only thing is that I have to change this index from k to m plus n minus k. So in this case, m plus n is 100, so I have to change it to 100 minus k. So what will happen then? This becomes a square root of 10 plus square root of 100, but instead of k, I put 100 minus k. So it becomes minus 100 plus k. And these 100s are gone. And then what I will get the sigma k goes from 1 to 99 square root of 10 plus square root of k. But if I ask you, what do you see now? You see that this is exactly the numerator. Okay? And if you don't mind, let me use letter n for numerator here. But if I do the same thing here, so if I do the same thing here, this will give me the sigma k goes from 1 to 99 square root of 10 minus square root of k, which is the denominator again. So what happens? The denominator that I started with is the difference between these two expressions, but this expression, according to this identity, turns out to be the numerator, and this expression, instead of this, based on the same equality, turns out to be the denominator again. So do you remember? I started calculating the denominator. So the denominator is equal to 1 over square root of 2, but multiplied by the numerator, minus 1 over square root of 2, multiplied by denominator again. And this is the golden rule here, so I hope that you can guess what I'm supposed to do. So I move this term to the other side and factor a d out. So it becomes 1 plus 1 over square root of 2 times d is equal to 1 over square root of 2n. And I prefer to get rid of fractions, so I multiply everything by square root of 2, so it becomes square root of 2 plus 1 times d, and on the right hand side I will have my n. But do you remember what we were looking for? We were looking for x, but x is the fraction, the numerator divided by the denominator. Okay? But instead of the numerator, I put the square root of 2 plus 1 times denominator divided by the denominator. And the denominators are cancelled, so what is left for me is just simply square root of 2 plus 1. And this is the final answer. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.